Good morning everyone, this is Mohna again. So here we are going to learn the factorization of cubic equations. So what exactly are cubics? So if we come to definition, cubics are nothing but polynomial whose highest form of degree or sum of exponents is 3. Okay, you can see here the basic form of cubic equation is ax cubed plus bx squared plus cx plus d. So what is important here? We need to have highest exponent as x cube. So that is a cubic equation. Just like we learned quadratic equations in which highest form is 2, and here it is 3. Like we can have some quadratic equation can have 2 roots. Okay, it may not have 2 real roots, but it can have 2 roots, 2 real roots or one or two complex roots. But when it comes to cubic equation, actually we can have maximum 3 roots, out of which at least one has to be the real root. Now we must have come across these cubic equations everywhere in our mathematics. So these are some of the cubic equations just to get a basic idea of how they look like. Now let's proceed to learn some more about them. So this is a graph of basic cubic equation. What is a basic cubic equation? Our equation is nothing but x cubed. So if we plot a curve, this is how it goes. Okay, as x increases, x cube also gives you more and more value. So the graph always goes from below to above right side. And irrespective of whether we change A, B, C or D, it takes a bit of different shape, but eventually it almost follows the same rule. This is just to indicate how it looks like. Let us learn something more about it. So if we take some cubic equation like this, x cube minus 4x squared minus 7x plus 10 is equal to 0. So how to defactorize it? Normally, when it comes to quadratic equation, what we do is we split the middle term. We split the middle term and we take something, one factor common out of those terms. So here we are trying the same method. We are splitting the middle terms both 4x squared and 7x, and we are writing them as 4x squared we are writing as x squared plus 3x squared, and coming to minus 7x we are writing it as 3x minus 10x. So now if you observe, we have something in common. What is it? We have x minus 1 in common. So you can take x minus 1 literally from almost every two terms. And so we get x minus 1 into x squared minus 3x minus 7. So here we got a quadratic equation which we can simplify much further in an easier way. We wrote minus 3x as minus 5x plus 4x. So we got these two roots. Now we got all 3 roots, 1, minus 2 and 5. So I just wanted to explain one thing here. The simplest way of solving a cubic equation is finding out one root somehow. Okay. And then you can easily reduce the cubic equation into a quadratic equation, and quadratic equations are almost basic, easiest to solve. Okay. Now if we try to indicate what are these roots in the form of a graph, you can see that if you plot this graph x cube minus 4x squared minus 7x plus 10, so this is how it looks like. Don't you think it is similar to what we showed earlier? It is similar, a bit twisted since we changed the coefficients here. Okay, so now you can see that we got 3 values as the roots, minus 2, 1 and 5. And these are the roots where it touches the x-axis, where the curve passes through x-axis. See, you can see minus 2 here, 1 here and 5 here. The curve exactly intersects the x-axis at 3 points, and these are the roots for us. And this will have further applications in various things. But for now, let us just try to learn how to defactorize them. Let us learn some more. For a cubic equation ax squared plus bx squared plus cx plus d, suppose we take p, q are to be its roots. So if someone remembers, for quadratic equation, sum of roots is minus b by a and product of roots is c by a. So similarly, here the equation is a bit bigger. So here we have 3 roots, and just like the same, we have sum of roots is minus b by a. Sum of product of those roots, 2 factors at a time, is c by a, and product of roots is minus b by a, this last coefficient. Okay. Now you can see that this basic knowledge is very much important. And when you have these three roots, P, Q, R, suppose you have only roots. So this is how you can put up the whole equation. X cube plus x square into P plus Q plus R plus x into PQ plus QR plus RP plus PQR. Now this is very important to remember, since just remembering it can help us a lot in solving out the square x roots. Now these are the basic terms. I am just using terms SCE and SO and SE in next slides. I can't mention each and everything, so I am just mentioning these terms here. I am using SCE for sum of coefficients of cubic equation, SO for sum of coefficients of odd powers instance x cube and x, and SE for sum of coefficients of even powers. That indicates x square, and we also consider this as an even power. Why? Because this almost is equal to x power 0 term. Okay. Now let us learn something new. We will brush up our basics regarding the remainder theorem. So whatever the main number will be there which we are dividing, that is nothing but dividend. So dividend is equal to divisor into quotient plus remainder, and whenever remainder is 0, that means divisor is actually a factor of dividend and it divides it completely without any remainder. Okay. So now if we get, suppose our divisor is x minus p, then our actual value is x. If x is equal to p, then that is nothing but your expression is equals to remainder. Let us learn some more information which can help us couple of corollaries. Let us take this basic equation again. So if divisor is x minus 1, okay, divisor is x minus 1, then we substitute x equal to 1. So 1 in place of x, then what we get? Our remainder will be a plus b plus c plus d. Remainder is 0. Then this divisor is nothing but a factor of our main expression, cubic equation. So we need to remember that whenever you have the sum of coefficients is 0, then x minus 1 is a factor. And let us take one more case. What about if the divisor is x plus 1? In this case, what happens is we substitute x with minus 1. And when we substitute x with minus 1, x odd terms like x cube and x, they become negative. So we get minus a plus b minus c plus d. And if sum of these two, all these coefficients is 0, then that indicates that sum of the coefficients of odd powers of x is equal to sum of the coefficients of even powers of x. So whenever you see a cubic equation and if you observe that sum of coefficients of odd powers of x is equal to sum of coefficients of even powers of x, then it automatically indicates that x plus 1 is a factor of it. So we just have to remember both of these, as these are very much helpful in coming problems. So now let us take one simple cubic equation and apply our knowledge to it. So we can actually solve this cubic equation by various methods. So let us explore method 1. So how are we going to take method 1? For solving a cubic equation, one of the most important thing is last term and sum of coefficients. So when you calculate sum of coefficients of entire equation, 1 plus 6, 7, 7 plus 11, 18, 18 plus 6, 24. You get sum of coefficients of equation is 24. And what is the last term? Last term is 6. You need to always check out for factors of the last term. So and these can repeat. So here if you take the factors, they can be either 116 or 123. But we need to take factors in such a way that the b term, okay, p plus q plus r should be equal to sum of the factors. Now 6 plus 1 plus 1 can't be equal to 6. Instead 1 plus 2 plus 3 can be equal to 6. Now let us check the other one, whether it coincides with it, whether we are going in the right direction or not. So let us calculate PQ plus QR plus R. And when we try to do it, we got exactly 11, which matches with the C term as well. So that indicates that whatever factors we took, they are the actual real roots of this cubic equation. And we can express the equation in terms of its factors. Now, one more method what we have is, we somehow guess one factor. Okay. Previously we learned one corollary where we need to observe the sum of coefficients of odd terms and even terms. Now if you see the odd terms x cube and x, sum of these coefficients is 1 plus 11 is equal to 12. And the other two, 6 plus 6 is equal to 12. So they are exactly equal. That means x plus 1 is a factor. We got a factor already. Now we have various methods like, you can divide by Paravartya method, factor method or any other method and guess out the quadratic equation. And also we can use the sum of coefficients as well. Remember we use coefficients method, sum of coefficients method for cross-checking the equations as well. So now what we do is, we already know that the sum of coefficients of the whole equation is 24. And we have one factor, x plus 1. Sum of coefficients of this factor is 2. So into whatever quadratic equation is there, that quadratic equation can have maximum value of 12. And we need to take, the first term must be x square since the final product is x cube. And the last term we are going to take it as say 6. And we just have to guess the middle term. Now we already know that this quadratic equation can only have the sum of coefficient value as 12 and x square term coefficient is 1 and last coefficient is 6. So 6 plus 1 7. So the middle term can be only and only 5x. So we got the quadratic equation as x square plus 5x plus 6. We can defactorize it already by splitting the middle term and we observe that 1 is to 3 is 2 is to 6. So we got x plus 3 and we are dividing x square term and first and last term of quadratic equation by this first term and second term of the factor and we get the remaining term. If someone has any doubts regarding this solving quadratic equation, so there is one more video on factoring quadratic equations. So please have a look on it. And so we can express it in terms of factors. Now if we have any one factor, or even by trial and error method, we can also use the Paravartya method, what we have learned earlier. This can also be termed as factor theorem. So now we are going to divide this polynomial by x plus 1. So since it is x plus 1, we are going to write it as minus 1. 1 comes here, 1 into minus 1 minus 1, 6 minus 1 5, 5 into minus 1 minus 5, 11 minus 5 6, 6 into minus 1 minus 6. So we got 0 here. That itself indicates that this is a complete factor of this cubic polynomial. And we got this x square plus 5x plus 6 quadratic equation also. So these are like various methods to solve this simple cubic equation. Now let us learn some more problems so that we can get sure of this method. Now we are taking one more simple cubic equation, x cube minus 6x square plus 11x minus 6. Now, why are we taking this? There is something beautiful about it. What is it? Did you observe the sum of coefficients? That is nothing but 1 minus 6 plus 11 minus 6. So, what is it? It is nothing but it is 0. And now, last term is as usual, we are taking minus 6. So, whenever we can consider the factors, as usual, we can guess them minus 1, minus 2, minus 3. This sum of the coefficients and the product and sum makes our job pretty easier in this case. So we are going to cross check it and then we are going to confirm that these three are factors of it. But one more method is, since it is 0, we can know that x minus 1 is a factor. So now we have got one factor. So you can divide it by cubic polynomial by factor method and immediately get an answer. So 1, 6 minus 6 plus 1 minus 5, 11 minus 5, 6. And this 0 only confirms that this is the perfect factor. And we got the quadratic equation x square minus 5x plus 6. And we are defactorizing it in the same way. We are splitting the middle term as minus 3x and minus 2x. 1 is to minus 3 is equal to minus 2 is to 6. So x minus 3 is one factor. We are dividing first term and last term by x and 3 minus 3 and we are getting the other factor as well. So here in the second method also we got all three factors. So the beauty of this problem is just to explore that what we can do if sum of all the coefficients is equal to 0. Now let us try to explore it much further. So now we are taking x cube minus 2x square minus 23x plus 60. So now we have to take both sum of coefficients, which is nothing but 1 minus 2 minus 23 plus 60 is 36, and also last term is 60. So we are going to consider the factors of last term no matter what. And now what happens is actually we have some small hidden tips inside. So we can see that sum of all the coefficients is not 0. Okay. So since it is not 0, we can't have 1 in it. Factor can be 1 or 2. Okay. So now what will happen? We can take a guess and select 3 numbers out of this whole lot which can make our job easier. This looks like a mental calculation. Factors seem to be more, but actually we can take a really quick, smart guess. So 60 can be a factor because 60 can divide 36 like this as one of its factors. 30 can't do the job as well. So as we filter more and more, we can, any term, if suppose 1 is a factor, then how do you express x plus 1 or x minus 1? So what you do, you add and subtract 1 from each digit and just do a mental check whether this product divides it. Okay. So 10, 15, 20, 30, 60, none of them really serve the purpose. 6 also doesn't serve. So we are left with only minus 3, minus 4 and plus 1. Okay, these 3 factors, if we add, we get minus 2, and if we multiply within each other and add, we get minus 23. So that makes our job easier. And we can also cross check. So that gives you a confirmation. So we wrote the factors as x minus 3 into x minus 4 into x minus 5. Now this is a process of mental guess. Okay, as you do more problems, you will be really comfortable with this process as well. Math becomes a hell lot easier when you do a lot of things in your mind and pen on your paper very less. And let us explore one more method. This is a method where we somehow do a trial and error and get one factor at least out of the other factors. Now we are going to divide this cubic polynomial using Paravartya method, and we get the quadratic equation very easy. 3 minus 2, 1, 1 into 3, 3 minus 23. So now you get quadratic equation and we are splitting the middle term. We wrote x as 5x minus 4x. Ratio matches pretty well. So we got first factor x plus 5 already. We are going to divide first term and last term by this factor and we get second one as well. So now we can express our cubic equation in the form of factors. X minus 3 into x minus 4 into x minus 5. I hope you understand this. Let us proceed to next problem. Now we are taking x cube plus 3x square minus 17x minus 38. So even in this case, we are going to consider both sum of coefficients and last term and its factors. Now you can see that previous whatever mental calculation what we did, that becomes a lot easier since this is bit closer, a multiple of the prime number. Okay, so we can cross check that sum is not 0 and the sum of odd coefficients of odd parts is not equal to sum of coefficients of even parts. So both plus 1 and minus 1 are out of scope. You can have 38 as a factor. No way it will divide 51. So that is out of scope. 19 is out of scope. So only possibility is plus or minus. Now if you take plus 2, you can easily say that calculate that this positive term is far lesser than the other negative term. So it's no way you get remainder as 0. So only possibility is x plus 2, that is x equal to minus 2. And since you have guessed out the factor, let us do Paravartya method, which both uses quadratic fraction as well as giving it 0 remainder. Only confirms that we got a right factor. Okay. So 1 into minus 2 minus 2, 3 minus 2, 1. 1 into minus 2 minus 19. So minus 19 into minus 2 gives you plus 38. So now this gave you x plus 2 as one factor and other one is x square plus x minus 19. Now this quadratic equation doesn't have any other real roots because some quadratic equations with if you are familiar with term discriminant, that is nothing but b square minus 4ac. You have to make a proper square root of it and you need to get proper integers so that you can have real roots. Otherwise, in other cases, you can't get real roots. Quadratic equation, there is no rule that both of them are real roots. You will always have at least one real root. Now, this is a perfect example of it. We have one real root that itself explains that cubic equations will always have one real root. Now, let us proceed to one more example. So, this is x cube minus 7x plus 6. You have two important things to consider. One is the x square term is missing. So it can also be called the depressed cubic. It is very different, interesting thing. And one more important thing is sum of coefficients is 0, guys. 0. We already got one factor. Since sum of factors is 0, we already know that x minus 1 is a factor. Now we are going to do division with parallel method. This makes our job pretty much easier. 1 into 1, 0, 1, minus 6, 1 into 1, minus 6. So, getting remainder 0, this confirms that we are on the right track and we got quadratic equation as x square plus x minus 6 equals to 0. Now, this we can simplify by saying x as 3x minus 2x. So, we got x plus 3 as a factor and we got x minus 2 as another factor. One more thing you need to observe is since we don't have any x square term, we wrote its coefficient as 0. Now let us move on this. We should learn some of things. So why are we exactly going for these cubic equations? Are we doing just because we are being told to solve the cubic equations to get more marks in mathematics exam? No. These cubic equations applications are wide. Like they are around everywhere around us in real world. If you take a tablet and after some time, how much that blood goes will be there in your blood after some t hours. So you have a cubic equation minus 2d cube plus 6d square minus 8t plus 8. Isn't that really amazing? And we have plenty of examples like whatever geometric object you take, whether it is ball or sphere or cube, you always calculate its volume through a cubic equation. And one more thing, then there are plenty of examples like if you want to calculate electrical resistance of a capacitor and what about the movement of an object, suppose a planet in space, you want to calculate, you use a cubic equation through Kepler's formula. And we also have cubic, you have higher applications of these cubic equations in CAD, curve, in solid modeling and graphics applications, and you can't even imagine. We see this cubic equation application every day daily. How many of us are familiar with Times New Roman, and in that Times New Roman, they use the cubic, curves in order to indicate whatever the matter we are reading right now. The small dot above I, that itself involves 4 cubic curves. Can you imagine? So this is how it is around us. So thank you guys, and please post your comments in the comment section below. Thank you.